Hi everyone, we're going to find vertical asymptotes of the graph of the function, and we're going to do it with limits. Basically, it's really what makes the denominator 0. So basically what we're going to do is see what happens when we take the limit as x approaches infinity, or from 0, sorry. So it makes the denominator 0 from the right, and that graph goes to infinity, and also from the left. So our therefore 0 is a vertical asymptote. Remember, it's a line. Same thing here on this one. I'm going to take the limit as x approaches 2, because that's what makes the denominator 0 from the right. That equals infinity. And also x approaches 2 from the left. Therefore, x equals 2 is a vertical asymptote. Alright, the next one, we're going to go ahead and take the limits. If you factor this is going to be x minus 2 times x plus 1. So we take the limit as x approaches 2 from the right, and we get I'm just going to put h of x, and that equals infinity. And then if you take the limit as x approaches 2 from the left of our function, which is this, that equals negative infinity. So 2 is a vertical asymptote, and we also have to check negative 1. And we check negative 1. So we check, put a negative there. That equals infinity, and the limit as x approaches negative 1 from the left equals negative infinity. So both x equals 2 and x equals negative 1 are vertical asymptotes. You should know that just because you set this to 0, and that gives you your vertical asymptotes. But this is the limit approach. And for this one, we do the same thing. We're going to check for x equals 0 for this piece, and x equals 1 for this piece. So you can take the limit as x approaches 0 from the right. Well, basically, let's do the ones first. The limit as x approaches 1 from the left of g of x, that equals infinity. And the limit as x approaches 1 from the right of g of x, that equals negative infinity. So x equals 1 is a vertical asymptote. Also, for the 0, we can just do the same thing. The limit as x approaches 0 from the left, and the limit as x approaches 0 from the right side of g of x and g of x. They both equal infinity. Therefore, x equals 0 is a vertical asymptote. Okay, the same thing here. We have x minus 2, x plus 2. So we're going to check the limits as x approaches 2 from the right of f of x, and the limit as x approaches 2 from the left of f of x. And this one's going to equal infinity. Well, actually, this one is negative infinity. And from the right, that is also, from the left, that's also negative infinity. No, from the right is negative infinity, and from the left is infinity. Sorry. I had these mixed up. So therefore, 2 is a vertical asymptote. And for the second part, the limit as x approaches negative 2 from the right, and the limit as x approaches negative 2 from the left. So from the right, that's going to be infinity, and from the left, from the right, that's negative infinity, and from the left, that's infinity. So therefore, x equals negative 2 is also a vertical asymptote. And for this one, there is none. There's no vertical asymptotes because there's no real numbers where the denominator equals 0. Only complex numbers. Same thing for this one. There's none or no vertical asymptotes. So if we do this one, this is going to be s minus 5, s plus 5. So we're going to take the limits for the 5, and we're going to go from the limit as s approaches negative 5 from the left of h of s, and the limit as s approaches negative 5 from the right of h of s. So this one equals negative infinity. This one equals infinity. So negative 5, x equals negative 5 is a vertical asymptote, and also 5. So we have limit as s approaches positive 5 from the left of h of s, and that equals negative infinity, and the limit as s approaches 5 from the right of h of s, and that equals infinity. So s equals 5 is also a vertical asymptote. This should be an s. And that's all. Thank you. Have a nice day. Bye-bye.